Hello everyone and welcome to lesson 5-8, Scale Drawings and Models. This lesson is found on page 224. If you're thinking about becoming a civil engineer or any type of engineer in the future, you might really like this lesson because you're going to use scale drawings and you're going to build them yourself, scale drawings. Now a scale drawing or a scale model, okay? The definition is right here, but in my own words, a quick definition is it's proportional to the size of a real one. So when you see it in scale size, you just see a miniature version, but all the dimensions are proportional to its larger size. So that if you were to multiply everything, let's say by 10 times the size, everything would increase by the same size to become its actual size. So let's see, a scale drawing or a scale model is used to represent an object that is too large or too small to be drawn or built at actual size. The length and width of objects on a scale drawing or model are proportional to the length and width of an actual object. The scale is determined by the ratio of a given length on the drawing or the model to its corresponding length on the actual object. Consider the following scales. Okay, we have 1 inch is going to be 3 feet. So for every 1 inch that you have to know that at real size it will be 3 feet. But the model is 1 inch. Or 1 centimeter will be 2 millimeters. And here we're going even smaller. 1 centimeter to 2 millimeters. Now we would use a scale drawing, for example, to draw things that we can't actually see. For example, space or our solar system. Or an atom. An atom can be so small that we actually have to draw a scale model of it because we can't really see it. Very important, whenever you're drawing a scale drawing or scale model, you must include a scale. So scales are written so that a unit length on the drawing or the model is listed first. So you have to know exactly how it will be converted so that you can see its real size. So for example, suppose a model of a dragonfly has a wing length of 4 centimeters. If the length of the insect's actual wing is 6 centimeters, what is the scale of the model? Okay, so 4 centimeters to 6 centimeters. So here we have the model size, which is 4 centimeters, and the actual size is 6. Not much difference, right? We would say that 4 is 1 centimeter. If we were to make a model length at 1 centimeter, what would be the actual length if it was 1 centimeter? Well, here you can see, boys and girls, that we went down by 50%. From 6 to 4, we went down by 50%. You see that? Okay? Because 50% of 4 is 2. And that's how much we went down from 6. So we would have to go down, we would have to here go up by 50%. So it should be 1.5, as you can see right there. We can also use cross product, as we learned in the previous lesson, where we multiply across. So now we would have 4x equals 6. So we have 4x equals 6. What do I have to multiply 4 to get 6? I would have to multiply by 1.5 to get 6. Or we simply isolate the x by bringing the 4 over to the other side. We divide 6 divided by 4, and we get x equals 1.5. Something to keep in mind is if the scale drawing and model have the same unit of measure, the scale can be written without units. This is called scale factor. Suppose a scale model has a scale of 1 inch equals 2 feet. Okay, so we have 1 inch, here's your scale, equals 2 feet. So 1 inch over, it's always 2 feet. 1 inch would be also 424 inches. Remember, every foot has 12 inches, so 2 of them would have 24, right? So here's your scale, 1 to 24. And this, we don't have to put the units because this is a scale factor. For every 1 inch, we actually have 24 inches. 1 unit on the model represents an actual distance of 24 units. So the model's length is 1 to 24, the size of the actual object's length. So here we have a model of a ramp, okay? The blueprint of a skateboard ramp shows that its length is 11.4 inches. If the scale on the blueprint is 1 inch to 6 feet, what is the length of the actual skateboard ramp? So here we go. Every 1 inch is 6 feet. So we could write something that looks like this, right? 1 second. We can write something like that. For every 1, we have 6. Let me change that to white. Right? So now for every 1, we have 6. So let's see, then we have 11.4 on the top. What did I do to the 1 to make it 11.4? I have to do the same to the 6, and this is where we can use cross product. Okay, this is where we're looking for our x. So we would use we would multiply 6 times 11.4, and that'll give us the value of x, right? So then we have something like this when we do our cross product: 1 times x, and 6 times 11.4, 68.4, and then I can simply isolate the x by bringing the 1 over and putting it there. But 68.4 divided by 1 is still 68.4, so x equals 68.4. You can take a look at that, and that's how they did it right there. Method 2. The actual length is proportional to the length of a scale drawing with a ratio of 1 to 6. Find the scale factor. Okay, 1 to 6, 1 to 72, or 1 to 72. Now remember, that is the scale. We're looking for the scale factor. The scale factor is when both become the same unit. You know that every foot has 12 inches. So 6 times 12 is 72. So our scale factor is 1 to 72. For every 1 inch, we will have 72 inches. And here's how we can say it. We can actually say that the actual length equals 72 times the blueprint length. So the ramp is going to be 72 times larger than the model. Let A represent the actual length. Let B represent the blueprint length. So A is the actual length, right? A is the actual length. And that means it equals 72 times the model. So this is the model size, and we multiply it times 72 to get the actual size. And you can see that that's how it was done right there. Okay? Now we can try this example here together. A map of a natural history museum shows that the dinosaur exhibit room is 7.25 inches wide. If the scale on the map is 1 inch to 8 feet, what is the width of the actual exhibit? So now we can find what our scale factor is by changing the 8 feet to inches. You know, for every foot you have 12 inches. So it would look something like this. 1 to 96. Okay, 1 inch, and here's 8 feet written in inches. And we're told that it's 7.25 inches wide. So it's 7.25 inches wide. So we need to actually find the real size. This is the model size. What is the real size? If it goes from 1 to 96, here's our ratio. Okay, 1 to 96. So we can do cross product. And when I multiply 1 times x, I get 1x, and then 96 times 7.25, I get 696. And once we isolate the x and bring the y over, we put it over 1, x is still going to equal 696 inches. And if we wanted to represent that in feet, we could also represent it in feet. Just simply divide this number by 12, which is actually exactly 58 feet. And there you have it. So that's what is the length of the actual exhibit room. Okay, so how do we apply this to scales? To construct a scale drawing of an object, use the actual measurements of the object and the scale to which the object is to be drawn. So we're going to use the actual measurement and then a scale. Are we going to make it half the size? Are we going to make it 1/8 of the size? And so on, so that you can make the scale size. Okay, here's an example. Leela is painting a mural. A mural is a large painting on a wall, usually a combination of many drawings and colors and so on. So she's painting the mural at the community center on a wall that measures 18 feet long and 12 feet tall. Make a scale drawing of the mural. Use a scale of 1/4 of an inch equals 3 feet. So every 1/4 of an inch on the drawing is going to equal 3 feet in real life. Use 1/4 of an inch grid paper. So you can see here our ratio. 1/4 of an inch in model size is going to be 3 feet in real life size. So we were told that it was 18 feet wide, right? 18 feet wide. So how many inches would that be if we were to draw it in a model size, a drawing? Well, we can use cross product to solve this. You multiply 1/4 of an inch times 18, so 1/4 times 18, and then you would divide it by 3. And you can see here in example 2, you can do the same thing for the height of the wall. The height of the wall was 12 feet, You could do the same thing, cross product, where you multiply a quarter times 12 and 3 times w, and then you isolate the variable by inverting the operation. So you want to isolate the w, you bring the 3, the coefficient, bring it over, and you divide so that you get 1 equals w. So w is 1 inch. And here's a visual of what we just did. 12 feet by 18 feet at a scale of a quarter inch equals 3. So you can see that each quarter inch here on the grid paper, let me make that bigger for you, is going to be 3 feet. So this is 3, 6, 9, 12, 15, 18, and again 3, 6, 9, 12. You see that each quarter inch in the grid paper is going to equal 3 feet, as is mentioned there. Okay, here we have to draw another model. An architect is designing a school courtyard. A courtyard is where everyone goes to play. Typically just an open paved area that is 45 feet long and 30 feet wide. So something like this, 45 feet long and 30 feet wide. Obviously this is a smaller version, but in real life this would be quite large. Make a scale drawing of the courtyard. Use the scale of half an inch is 10 feet. So half an inch equals 10 feet. Okay. So every half inch that I have on my scale here, a half an inch, right there, another half inch, another half inch, in real life it'll be 10 feet. Okay, let's move this out of the way here to the side, and let's work with what we have. We have 0.5 of an inch for every 10 feet, and we want to convert that to, let's say the height, the width of the wall is 30 feet, and we're looking for x. Half times 30 is going to give me 15, right? 10x. Because whenever you multiply a number times a half, you get half of that number. So it's 15 equals 10x, right? I did my cross products. And now I'm going to divide, bring the 10 over to the other side. So x is going to equal 1.5 inches. So when I draw it, I need to draw 1.5 inches. And if we actually look at the answer, you'll notice that 30, when we work with the 30 feet as we were working here, is actually 1.5 inches. Remember that each little square on the grid is a quarter of an inch. So we have a quarter, a half, 3/4, and 1. So 4 squares is 1 inch. And then here we have another quarter and another half together. So this is 1, up to here, it's 1.5. So it is 1.5 inches. Okay? And we could do the same to figure out what 45 feet is in our scale model. We have half inches every 10 feet. When we make it 45 feet, what do we do here? So let's see, what do we have to do to make sure that we cross product. When you multiply 45 times a half, you will get half of 45, which is 22.5 equals 10x. You invert the operation so that you can isolate the variable, and you bring that 10 over, and now you're going to divide this. So remember, when you divide any number by 10, you actually move the decimal over 1, so your answer will be 2.25 is x. So 2.25, is that right? Remember, every little square is a quarter of an inch. So here we have half, a whole, another half, another whole. So up to here, it's 2 inches. You see that? It was a quarter, a half, 3/4, 1. Quarter, half, 3/4, and 2. So there's 2, and then we have one little quarter right there. So it's correct. It's 2.25 inches. As we did the last lesson, please go ahead and now do the guided practice on your own, and we'll check it in class. But let's do the independent practice in class together. Now, there's a lot to do. As you can see right there, this is something I'd like to do with you. And there's a lot more on the back. Okay, see you in class, everyone.